Hey everybody! So today this tutorial is going to focus on how we run linear mixed effects models. Now what we're going to be doing is doing them starting off in SPSS, then we'll move to JASP, and then we'll move to R. Okay, so let's get into doing linear mixed effects models. So here we are in SPSS. And what I've done is I've opened up the file called politeness.sav. And what this is doing is just looking at the frequency of voices, so the pitch of different people's voices, and this is for females and males, as a function of whether or not they are speaking in a polite manner or an informal manner. Now, here we've got multiple repeats from the same subject, and what we want to do is be able to use all of these data points. So we're going to use a linear mixed effect model. Now, in SPSS, the way we do that is we go up to Analyze, scroll down to Mixed Models, and we're going to select Linear. Now, this first one asks us whether or not we have correlated or uncorrelated terms. And we're just going to click Continue because we're not sure if we've got uncorrelated terms. We're just going to proceed with the model the way it is. So what we see is we get an input box where we ask for dependent variables and factors. So here, because we're going to be modeling frequency, that's our dependent variable. Now in here, we want to put our factors. Now those are sex and attitude at this point. But the other thing we need to do is we need to also put in as a factor our random factor. And our random factor in this situation is going to be subject. We could also add scenario, but we won't do that at this time. So we're just going to add that as a factor as well. Then we move on and we can define what are fixed and what are random factors. So I'm going to click on Fixed, and I'm going to select my fixed factors of sex, hold down Shift and attitude, and add that in. And we can see it gives me my model for sex, attitude, and an interaction between those. I click on Continue. Then I want to select Random to select my random factors. So I'm going to put in this case, just subject into the model as a random factor. Hit Continue. Next, I'm going to select estimation. I don't have to worry about. Statistics, I can select descriptive statistics, and then maybe parameter estimates if we want to be able to compare between different programs as well. Finally, for estimated marginal means, I'll select overall and all of the different factors. Put them into display means for and select compare main effects. Remember, SPSS isn't going to let us do post hoc tests on interactions, but we'll at least be able to look at the main effects. So I'm going to select Bonferroni here and click on Continue. Finally, I'm going to click on OK to run the analysis. So here's the output that we get. What we see is we have descriptive statistics, which has the different subjects in the different conditions, and in terms of the mean, standard deviations, etc. Now, if we scroll down, we want to look at our type 3 tests of fixed effects. This would be analogous to running our ANOVA on the model. And what we're going to look at is the impact of sex, and we see that we've got an F ratio of 26.299, degrees of freedom being 1 and 4.008, and our p-value is 0.007. Our effect of attitude is 9.152, and our degrees of freedom are 1 and 75.018, and our p-value is 0.003. Finally, we've got our sex by attitude interaction effect, and what we see is that is not significant at 0.209. So what we do is we get a table showing our estimates of our fixed effects as well, that we could calculate the different values from this table as well. I'm going to scroll down And then we have our estimates of marginal means and the comparison between those. So first of all, we've got our estimated marginal means for sex. So with females at 246 and males at 138 when collapsed across politeness or attitude. And then what we do is we have the pairwise comparison. So males and females are different from one another and our p-value is 0.007. But that's not unexpected because that's what we saw in our ANOVA table. Furthermore, we see our estimated marginal means for attitude, whereas informal had a higher frequency than polite. And we see the difference here is 19.305 hertz, and it's got a p-value of 0.003. Now, because our interaction was not significant, we don't have to worry about that. We do get our estimated marginal means for all of the different conditions here as well. Okay, so that's it for SPSS. Let's move on to doing this analysis in JASP. So I'm going to open up JASP, and I'm going to open up our file, which will be called politeness.csv. So I'm going to select politeness.csv, and we see that it opens the file, and we've got the same data that we saw in SPSS. The way we're going to run this model in JASP is we select mixed models, and then we're going to select linear mixed models. Now, into the different boxes, I'm going to select as our dependent variable frequency, and I'm going to select as our fixed effects sex and attitude. Then the last thing we need, and note, it tells us here this analysis requires at least one random effects grouping, and that is subject. So I'm going to add that in under random effects grouping factors. And now it calculates the model. And what we see is this looks a little bit different to what we saw in SPSS. So if I click on the drop down for model, what we see is that it's actually selected to include random slopes by subject for all of the terms, including sex, attitude, and the interaction term. Now, to make this look similar to SPSS, we'll just disregard right now for random slopes, because what we see here is we also get a warning telling us that our model fit is singular. That may suggest that the model that we've specified is a little too complex for the amount of data that we've got. So if we remove some terms, such as random slopes, it may decrease that problem. So if I'm going to get rid of the random slopes, and it recalculates our mixed model. Now, I'm going to look under options, and I'm going to select a model summary, fixed effects estimates. And what we see is what I've got is the ANOVA output that looks very similar to what we saw in SPSS. So the effect of sex with degrees of freedom 1, 4.01, F ratio is 26.299, p-value is 0.007. For attitude, our degrees of freedom are 1, 75.02, F ratio is 9.152, p-value equals 0.003, and sex by attitude, again, we've got our degrees of freedom and F ratio, and note it's not significant, p-value is 0.209. Now, what we have is our fixed effects estimates down here, and note that the intercepts and interactions are slightly different than what we might see in different programs, but that's only because it's defining what the reference category is slightly differently depending on the program. Now, if we want, we can see our estimated marginal means by clicking on the drop-down and adding in the two factors that we've got. And now what that does is that gives us an estimate of our marginal means across the different conditions that we've got here. So That's pretty much all there is to it in doing the linear mixed effects models in JASP. So next, we'll move on to R. Okay, so now here we are in R, in RStudio, and the first thing I'm going to need to do is load our data file. So that's called politeness.csv, and I'm going to open it up by importing the data set. Okay, so I'm just going to call this politeness.data. And I'm going to select, it's got headings and everything else looks good in here. And I'm going to import that data. Okay, so the first thing I need to do is I want to check that sex and attitude are both defined as factors. So I'm going to use a command called str, which tells me the structure of my data frame. So if I do str politeness.data and run that, what we see is that subject, sex, and attitude are all character. So what I'm going to do is maybe change each of those so that they are factors. And the way we're going to do that is I'll start a new set of commands up here, and I'll erase everything in the middle, and this is going to be politeness.data. Before I do that, though, I'm going to just rewrite a couple of the columns in politeness data frame. So the first one is going to be politeness.data, and I want to use sex. Into that, I'm going to rewrite its own data, but I'm going to use the function as.factor. Then I'm just going to use that same command. A couple more times, and one is going to be for attitude. And the other one is going to be for subject. Now I'll just run those three commands. Now if I run the str command again, structure, now we see that subject is a factor with 6 levels, sex is a factor with 2 levels, and attitude is a factor with 2 levels. Okay. So we're on the right track now. So the first thing that we really want to do is we want to create the model that we need. So let's just call this politeness.model. And into that, we're going to use the LMER function. Linear mixed effects in R. Now, it's important to remember that we're going to need to load this library beforehand, or load this package. If I scroll down and look, I need the LME4 and LMER test packages to be loaded. So I could put that up above, just so I remember. Library LME4 and library LMER test. Okay, so first thing, like I said, we're going to create this model using the LMER function, so linear mixed effects in R. And what we want to do is look at frequency as a function of sex interacting with attitude. Then what we need to do is add our random effect. And the way we do that is by just using a 1 and the bar. And the bar is located right above your return or enter key, right beside the backslash. So it's just a straight up and down bar. And then you have to specify your random effect, which in this case we're using subject. Now there's a couple of other commands we can put in here, but at this point, this is all we need to run the model. The next thing we're going to want to do is we want to provide a summary of that model. Summary politeness.model, and then we'll run ANOVA of that model. So that should be good for now. So if I run that entire set, as you've come to expect from me, I've made a spelling mistake. It's frequency by sex by attitude. You probably picked these up before I do. Let's try running that again. Okay, so what it's done is it's created that model. And if I scroll up, we can see it tells me the output here. It starts off by giving me the formula that I used to calculate the model. It gives me my random effect. We're not going to worry about that right now. And then we have our fixed effects, which is our intercept, sex, attitude, and our interaction effect. What we see is in that model that sex is significant, attitude is significant, and the interaction is not. We also see that when we run the ANOVA of the model. We have sex, and we can report this as sex 1, 4.008 equals 26.299, and p equals 0.007. Attitude, again, degrees of freedom, 1, 75.018 equals 9.1517, p equals 0.003, etc. So what we see here from our fixed effects is that we can actually calculate our mean values. So let's, first of all, create a box plot of our data. And then let's also do an estimated marginal means on our data. So into this, after we run the ANOVA, I'm going to create a box plot of frequency as a function of sex by attitude. The next thing I want to do is I want to output EM means of politeness.model, comma, pairwise. Now I can do it. I'm going to do a function of sex by attitude. However, I could just do pairwise by sex or pairwise by attitude, or I can do the interaction effect. But let's do all of those just so we can see all of the interactions. So I'm going to run that entire set again. And this time what we see is we get a box plot of our data. It's behind me here. And it's also failed to output my EM means because I didn't load the package. So I'm just going to go into packages and I'm going to make sure I load that package, and it's right there. EM means, library, EM means. I should put that up in the top so I remember. Okay, let's run that again. Like I said, it creates a box plot for me. And I spelled it wrong again. Politeness.model. Like I was saying, it creates our box plot. And now this time, in addition to outputting all of the fixed effects, it gives our estimated marginal means and contrasts between those using a p-value adjustment of 2 keys. So what it does is it gives me p-values for any of the contrasts that I want to look at. But what's interesting here is we can see our estimated marginal means here and how they relate to the fixed effects. So, for example, female informal is 261 hertz. And that is the intercept because it's the reference category. And if we look at what does being male do to change that, we get a decrease of 116 hertz. And that would just be that difference from here down to here. And we see that again in our estimated marginal means. If we look at female informal and I subtract 116 from that, I should get 145, or rounding 144 in this case. And in this case, we could see that all of these, the intercept and then the impact of the model with the different factors, lead to our marginal means here. Okay, the last thing we might want to do in R is do a couple of quick diagnostics on our model. So one thing we can do is we can plot the model. So simply plot politeness.model. And in fact, I can just run that from here and Control Enter. And what we're looking for is this is our fitted versus our residuals. And we're just wanting to make sure that these look like they've got a reasonably similar amount of spread across them. The next thing we can do is take a look at the histogram of our residuals. And we're just going to see if we have reasonably normally distributed residuals. So it's hist residuals polite. See, this is right. This is why I should probably just select it, polite, from it, rather than trying to type it out because I make lots of spelling mistakes. I can run that, and we see I end up with a reasonably normally distributed set of residuals here. And potentially, if I want to do one more, I could do a QQ plot of the residuals as well, which would basically be the same command, but I'm going to use QQ norm and just run that. And I get my QQ plot of my theoretical quantiles and my sample quantiles. And we want those to be reasonably aligned on a diagonal. Okay, so hopefully that gets you started on doing linear mixed effects in R, in JASP, and in SPSS.